Today we will discuss the sign of trigonometric functions in different quadrants. Before that, let us explain how these 6 trigonometric functions are explained here. Cos of minus theta is equal to cos theta. Sec of minus theta is equal to sec theta. Sin minus theta equal to minus sin theta. Cosec minus theta equal to minus cosec theta. Tan minus theta is equal to minus tan theta. And cot of minus theta is equal to minus cot theta. See, this angle is theta. This angle is theta. So what we have done, here x dashed, ox and y dashed are 2 coordinate axes, and a circle is drawn of unit radius with O as center. It is a circle of unit radius with O as center. Now see, cos of minus theta. Cos of minus theta, what do you know? Cos theta is equal to base by hypotenuse. So cos of minus theta in this triangle, cos of minus theta is equal to what? Base by hypotenuse. This is x by 1, that is equal to x is equal to x by 1. This x by 1 from the upper triangle, you see x by 1, which is equal to cos theta. So in case of cos theta, in case of cos, we get cos of minus theta equal to plus cos theta. If it is minus, though it is plus. And in the other cases, sin and tan, the sin minus theta becomes minus sin theta. See how sin minus theta in this triangle, sin minus theta is equal to, what do you know? Perpendicular by hypotenuse. So sin minus theta is equal to, what is this? This is minus y by 1. This minus y by 1 can be written as this minus remains minus, and y by 1 come to the upper triangle. Y, this is y. Y by 1 is equal to what in this triangle? Y by 1 is equal to sin theta. So we get minus sin theta. So sin of minus theta is equal to minus sin theta. In the same way we can get tan minus theta is equal to minus tan theta. You can do in this way also. Tan minus theta is equal to sin minus theta over cos minus theta. Now sin minus theta equal to, just now we have done sin minus theta equal to minus sin theta, and cos of minus theta is equal to cos theta. So minus sin theta over cos theta equal to minus tan theta. Now we'll come to this after we will go here. Sign of angles. Sign of angles. How do we take the sign of angles, or how we measure in some cases the angles? Here, if this angle is theta, if this angle is theta, then see clearly from here to here it is theta. In this figure, from here to here, this is theta. Then what will be the measure of this angle? See, the angle, the direction of the angle is opposite. So what will be the angle from here to here? So this is theta. So this angle is what? This angle is from here to here. If we go, this is minus 360. And if you go from here to this theta, then minus 360 plus theta. If you take minus common, see minus 360 minus theta means if you break this, if you break the bracket, then you will get the same thing, minus 360 plus theta. Minus 360 plus theta. Or we can say minus 360 minus theta. Now, here the angle lies in the first quadrant. We denote it simply like this. This is theta. This angle lies in the first one, theta. But when the angle lies in the second quadrant, how do we denote the angle? So theta will be taken from here to here, because this angle lies in the second quadrant. This angle lies in the second quadrant. So theta will be from here to here. When it is in the third quadrant, means The angle lies in the third quadrant. This angle lies in the third quadrant. So the angle will be denoted from here to here. When the angle lies in the fourth quadrant, the angle will be denoted from here to here. Okay. Now we have 4 quadrants. All trigonometric, here you have written first, second, third, fourth. There are 4 quadrants. First, second, third, fourth. And also you have written all sine, tan, cos. All sine, tan, cos. Why do we write like this? We have written all means all trigonometric functions are positive in the first quadrant. Here all trigonometric functions are positive in the first quadrant. Here is, see, sine in the second quadrant. Sine is positive. Sine, and what is the reciprocal of sine? Cosec. So sine and cosec will be positive in the second quadrant. All the other trigonometric functions are negative in this second quadrant. Only sine and cosec will be positive, and all other trigonometric functions will be negative in the second quadrant. Here in the third quadrant, all sine, tan. In the third quadrant, tan is positive. So if tan is positive, then cot is also positive. Reciprocal of tan is cot. So tan and cot are positive in the third quadrant, and the rest means all the other trigonometric functions are negative in this third quadrant. Here cos is positive, and cos and sec are positive, and all the other trigonometric functions are negative in the fourth quadrant. So let us repeat. So all sine, tan, cos, all are positive in the first quadrant. Sine is positive in the second quadrant. Sine and cosec, reciprocal of sine is cosec. Sine and cosec are positive in the second quadrant. Rest are negative. Tan and cot are positive in the third quadrant. Rest are negative. Cos and sec are positive in the fourth quadrant. Rest trigonometric functions are negative in the fourth quadrant. We need to know this term, coterminal angles. What are coterminal angles? If the difference between two angles is in the form of 2n pi, means if coterminal angles differ by 2, actually coterminal angles differ by 2n pi. If two angles differ, if the difference between two angles can be expressed in the form of 2n pi or n into 2 pi, this is 2n pi or n into 2 pi or n into 360, then the given angles are said to be coterminal. Let us take an example. Suppose A equal to 165 degree and B equal to minus 335 degree. Then what is the difference between these two angles? A minus B will be 165 degree minus of minus 335 degree. By simplifying, get 500 degree, which is not a multiple of 360. See, 500 is not a multiple of 360. So it is not in the form of 2n pi or n into 2 pi or n into 360. It is not in the form of n into 360 form, means this form. So these angles A and B are not coterminal. A and B are not coterminal. Next example, suppose A equal to 14 pi by 9 and B equal to 50 pi by 9. Find the difference between these two angles. B minus A equal to, get 50 pi by 9 minus 14 pi by 9. After simplifying, we get 4 pi. 4 pi can be written as 2 into 2 pi, means in the form, we are trying to write in the form of n into 2 pi. So 2 into 2 pi, n into 2 pi. See, it has come in the form 2n pi or n into 360. We can write it also 2 into 360. So since it is in the form of n into 360, this form, n into 360, this form, these two angles A and B are coterminal. Reference angle. What is a reference angle? We have drawn 4 figures. So in the first figure, when the angle lies in the, we have discussed there are angles in the first quadrant, angle in the second quadrant, angle in the third quadrant, and angle in the fourth quadrant. Suppose when the angle lies in the first quadrant, this alpha dash equal, we have taken alpha dash equal to alpha. What is alpha dash? I am telling you in the next figure. What is alpha dash? Alpha dash equal alpha. Here in the second figure, when the angle lies in the second quadrant, see, this angle is alpha. From here we have considered this angle up to here alpha, and this angle we have taken as alpha dash. So what will be alpha dash? The measure of alpha dash. Alpha dash will be pi minus alpha. If we subtract this alpha from pi, we will get this angle. So this angle is pi minus alpha, and I have written this angle, I have denoted this angle as alpha dash. This alpha dash is called the reference angle. Means, what is the definition of a reference angle? The angle made by the terminal side of the angle. Here is the angle alpha is from here to here. So what is the terminal side of the angle? Angle कहाँ पे जाके खत्म हुआ है? यहाँ पे जाके खत्म हुआ है. So this is the ये हो जाएगा terminal side. So this is the terminal side. The angle formed by the terminal side of the angle and the x-axis. Terminal side of the angle and the x-axis is called the reference angle. So this angle is alpha dash. This angle is denoted by alpha dash, which is equal to pi minus alpha. Similarly, in the third figure, when the angle lies in the third quadrant, see the angle alpha is from here to here, alpha. So what is alpha dash? What I said, तो alpha जाके कहाँ पे खत्म हुआ है? यहाँ पे खत्म हुआ है. तो ये टर्मिनल साइड हो गया. तो ये टर्मिनल साइड और ये हो गया x axis. So the angle made by the terminal side and the x axis is what? This angle. Angle made by the terminal side and the x axis is what angle? This angle. This angle is called the reference angle. So what will be the measure of alpha dash? Alpha dash is equal to from here to here alpha, and if we subtract this pi, then you will get this angle. From here to here, this is alpha. Alpha से इसको माइनस कर देंगे तो e बचेगा. तो alpha minus pi is equal to alpha dash. Alpha dash is equal to alpha minus pi. What is alpha? Alpha is an angle in the standard position. This alpha is an angle in the standard position. This alpha is an angle in the standard position. This alpha is the angle in the standard position. Okay. Now see, in the fourth, when the angle lies in the fourth quadrant, in the fourth figure, when the angle lies in the fourth quadrant, we have taken this angle as alpha. From here it comes in this way and ends here. Okay. यहाँ खत्म होता है एंगल. तो एंगल का टर्मिनल साइड ये हो गया. So this is the terminal side. और x axis कहाँ है? यहाँ पे है x axis. What I said, the angle made by the terminal side and the x axis is called the reference angle. So the reference angle over here is this angle, which is denoted by alpha dash. What will be the measure of alpha dash? What will be the measure of this angle? This is from here to here it is 2 pi. From here to here it is 360, 2 pi. From here to here it is 360. 360 से इसको हम माइनस कर देंगे. पूरा 360 से इसको माइनस कर देंगे. क्या बचेगा? ये वाला पोर्शन बचेगा. So this is alpha dash. कौन वाला एंगल बचेगा? ये वाला एंगल बचेगा. This is alpha dash. This angle is alpha dash. So this angle is alpha dash. So the reference angle, what is reference angle? So reference angle is the angle made by the terminal side of the angle and the x-axis is called the reference angle. Now suppose the question is given, find the value of cosec minus 33 pi by 4. So what to do? We know cosec of minus theta is equal to minus cosec theta. So cosec minus 33 pi by 4 can be written as minus cosec 33 pi by 4. This minus comes here. You have to write the reason here. I have not written, but you know. So minus cosec 33 pi by 4 is equal to minus cosec 33 pi by 4. If you multiply pi, that is put the value of pi equal to 180 degree, you will get 1485 degree. Put the value of pi equal to 180, then you will get minus cosec 1485 degree is equal to minus cosec. Now what to do? You have to write this angle, this 1485 degree, whatever will be given here, you have to write in the multiple of 90. You have to write this angle in the multiple of 90. So this 1485 can be written as 16 into 90 plus 45. 16 into 90 degree plus 45 degree, which is equal to 1485 degree, is equal to minus, here minus. Now see, if the multiple is even, here it is 16, it is an even number. When the multiple is even, then cosec will be cosec, sine will be sine. Suppose if it is sine here, so sine will be sine, cos will be cos, tan will be tan. If it is even, if the multiple is even. But if the multiple is odd, then sine will be cos, tan will be cot. In this way we'll do some questions. Okay. So since it is even, so this cosec will be cosec. If it is even, if there is sine, sine will be sine, tan will be tan if it is even. But if it is odd, then sine will be cos, tan will be cot. In this way we will do some other questions. Now here it is cosec 16 into 90. So it is an even number. So cosec will be cosec. It will not be changed. Cosec, and you have to put this angle, cosec 45 degree. It is even number. So cosec, for even number, cosec is not changed. Cosec will be written as cosec, and we will put this angle, cosec 45 degree. Now you have to see the sine. Means now you have to see 16 into 90 plus 45 lies in which quadrant? 16 into 90 plus 45 lies in which quadrant? 16 into 90 means this is 1, 2, 3, 490, 490, 890, 1290 and 1690. If we rotate in this way, 1690 is completed here, plus 45, plus 45. So 45 will lie somewhere here, 45 will lie somewhere here. Means this lies in the first quadrant. Since in the first quadrant all the trigonometric functions are positive, so cosec 45 degree, the cosec 45 degree, before that we will put plus. We have to see the sign from this step. We have to put the sign seeing this step. We have to put the sign here seeing this step. We have to put the sign here seeing this step. So cosec 16 into 90 plus 45, it lies in the first quadrant, and we know all the trigonometric functions are positive in the first quadrant. So this cosec 16 into 90 plus 45 will be plus cosec 45. If it lies in the second quadrant, suppose if it is 17 into 90 plus 45, if it would be 17 into 90, if it would be 17 into 90 plus 45, then what we would see? 17 into 90 means here it's 16 completed, then 17 into 90 plus 45. It would lie somewhere here. In that case, if it is 17 here, then cosec would be what? Sec. And it would lie in the second quadrant, mean cosec would be what? Plus or minus? Cosec is also plus here. Cosec is also plus here. Okay, because sine and cosec are positive in this second quadrant. We'll come to this question next. Now, cosec 45 degree. Now put the values, minus of cosec root 2, that is equal to minus root 2. Now sec of minus 22 pi by 3. Sec of minus theta is equal to sec theta, we know. So sec minus 22 pi by is equal to, can be written as sec 22 pi by 3. Now 22 pi by 3, put pi equal to 180 degree. You will get sec 1320 degree. We change this pi into degree. Okay. This 1320 degree, I told you that you have to write in multiple of 90. I told you that you have to write this in multiple of 90. So if you write in multiple of 90, you will get 14 into 90 plus 60, which gives 1320. Now, since it is even, 14, the multiple is 14, even number. When it is even, sec will be sec. When it is even, sec will be sec. It will not be changed. Sec and this angle, sec 60. You have to see this line. You have to see this line. From this line, we'll now see sec 14 into 90. 14 is even. So when it is even, sec will be sec. It will not be changed. Okay. So sec 60. Now from this line, you have to see what will be the sign here, minus or plus. means you have to see, you have to go to the quadrants. Now 14 into 90 plus 60 lies in which quadrant? You have to see. 14 into 90. This is 490, 890, 1290 plus 1390, 1490 plus 60. Means this will lie somewhere in the third quadrant, in this quadrant, third quadrant. 190, 290, 490, 890, 1290, 1390, 1490 plus 60 degree. So this will lie somewhere here in the third quadrant. In the third quadrant, sec, you have to see this line, sec. In the third quadrant, sec is negative. Only tan and cot are positive. Here sec is negative. So we are putting here minus. So we are putting here minus sign. Okay. So minus sec 60 is equal to minus 2. So if you understand these questions, these two questions, then you can write all the other results just calculating mentally. There are many results written in the books to commit to memory, but no need to commit to memory. Simply you go in the multiple of 90. Now see, cot pi by 2 plus x. So cot pi by 2 means cot 90, 1 into 90 plus x. Since it is 1, odd number, so cot will be 10. Cot will be 10. So tan, cot will be 10. Tan x, this angle you have to put, tan x. But what will be the sign? 1 into 90, 1 is odd. For that, cot is written as tan, tan x. Now 1 into 90 plus x, it lies in which quadrant you have to see? 1 into 90, this is 90 plus x, somewhere in the second quadrant. So in the second quadrant, sign is positive. In the second quadrant, sign is positive. Sign and what? Cosec. Sign and cosec are positive. The rest trigonometric functions are negative. So here cot is, you have to see this line. Here cot is negative. So that's why this negative sign minus comes. Similarly, cos pi minus x. Cos pi minus x. Pi means 2 into 90. 2 into 90 minus x. 2 is an even number. 2 is an even number. So since it is even, when it is even, cos will be cos. If it is odd, suppose if it would be 3, then cos would be written, cos would be changed to sine. Here you would write sine. If it is 3, if it is 5, if odd number is here, then you will write here sine. Okay? Since it is even 2, if it is even here 2, 4, 6, then cos will be written as cos. It will not be changed. Here cos 2 into 90 minus x. So cos x. Now you have to see the sign. What sign would be there? Minus or plus? Now come to this step. 2 into 90 minus x. 190, 290 minus x. So you have to go in the opposite direction. Minus x plus x. You have to go this direction, and minus x we go in this direction. Okay. So 2 into 90 minus x means it lies in the second quadrant. Somewhere in the second quadrant. In the second quadrant, cos is what? Cos is negative. In the second quadrant, cos is negative. So you have to see this sign, this line. Cos is negative. That's why we are putting here negative, minus sign. Similarly, sin pi plus x. Pi, sin pi is equal to 2 into 90. Pi is equal to 2 into 90 plus x. Now since it is 2 even number, sin will be written as sin. So sin x. Then you have to see the sign, whether it is plus or minus. How to find? Sin 2 into 90 plus x. You see this value lies in what quadrant? 2 into 90 plus x. 190, 290 plus x. Means it will lie in the third quadrant. In the third quadrant, tan and cot are positive. Other trigonometric functions are negative. So sin 2 into 90 plus x, this 2 into 90 plus x, this sign lies in the third quadrant. So this will be minus. Okay. Tan 2 pi minus x. 2 pi means 4 into 90. Tan 4 into 90 minus x. Since it is 4, even number, tan will be written as tan x. Since it is even, tan will be tan. So we will write this angle tan x. Now you have to see whether it will be minus or plus here. You have to put the sign. Now see, from the quadrant, 4 into 90 minus x. 190, 290, 290, 390, 490 minus x means it will lie here in this fourth quadrant. In this fourth quadrant, cos is positive. In this fourth quadrant, tan is negative. Cos positive. In this fourth quadrant, tan is negative. So we will put minus here. Now cos 3 pi by 2 minus x. 3 into pi by 2. 3 into 90 minus x. Since it is odd, so cos will be written as sin x. Cos will be written as sine and this angle x, sine x. Now whether it would be minus or plus. Now come to the quadrant. 3 into 90 minus x, 190, 290, 390 minus x, this direction, opposite direction. So it will lie in the third quadrant. In the third quadrant, cos is negative. In the third quadrant, cos is negative. Where to see all this line always. So in this quadrant, cos is negative. So put negative sign. Now, from all these things, these results, you can commit to your memory very easily. From this, if you understand this, you can commit to your memory these results very easily. Sine 2n pi plus theta is equal to sine theta. Put any value of, put any integer, any value of, this is integer, cos 2n pi plus theta, any integer n is any integer, and theta any real number, theta any real number. Put, you will get sine theta. Cos 2n pi plus theta is equal to cos theta. Tan n pi plus theta is equal to tan theta, and cot n pi plus theta is equal to cot theta. Sec 2n pi plus theta is equal to sec theta, and cosec 2n pi plus theta is equal to cosec theta. You put any real number theta and any integer n. You will get in the same way, in this way, you will get all these results. Now, cos A minus B, you have to learn these four formulas. Cos A minus B, learn by heart. Cos A minus B is equal to cos A cos B plus sin A sin B. Cos A minus B, when it is minus, here it is plus. And cos A plus B equal to cos A cos B minus sin A sin B. Only here it is plus, here it will be minus. If it is minus here, it will be plus. Cos A cos B plus sin A sin B. Then just the sign is in place of plus, it is minus. So cos A cos B minus sin A sin B. Sin A plus B equal to sin A cos B plus cos A sin B. And here it is plus, in case of sin plus, here will be plus, and sin A minus B, here will be minus. It is also sin A cos B minus cos A sin B.